We are going to begin this lesson by going over the Lesson 18 homework, so go ahead and grab that and make sure it's in front of you, and then we're going to begin. Number 1 says, shade in squares on the grid below to create as many rectangles as you can with an area of 18 square centimeters. So if it's asking for the area, I'm going to know that when I multiply the length and the width of these rectangles, they're going to have to equal 18 square centimeters. So as you can see underneath the grid to the right, I wrote down area of 18 and I listed all the multiplication ways to create 18. So these are the different rectangles I can make. So I can make a rectangle of 1 times 18, of 2 times 9, and of 3 times 6. So I used those multiplication to draw the rectangles inside the grid and make sure that you label them with the length and the unit number. So 18 centimeters, 1 centimeter. So I drew those three. Of course, yours can be 2 times 9 going the horizontal way and 3 times 6 going the vertical way as long as you have these numbers because these are the only ways you can create an area of 18. Number 2 says find the perimeter of each rectangle in problem 1 above. So for 18 times 1, I'm going to add up all the side lengths. I'd like to do it with the like numbers together, so I did 18 centimeters plus 18 centimeters plus 1 centimeter plus 1 centimeter. This creates 36 centimeters plus 2 centimeters. So for the perimeter of the 18 times 1, I have 38 centimeters. Next, I did my perimeter for my rectangle that is 2 centimeters by 9 centimeters. 9 centimeters plus 9 centimeters plus 2 centimeters plus 2 centimeters. 9 plus 9 is 18 and 2 plus 2 is 4. 18 plus 4 is 22 centimeters. And lastly, I did the 3 times 6. So adding up the side lengths, I get 6 centimeters plus 6 centimeters plus 3 centimeters plus 3 centimeters. 6 plus 6 is 12, 3 plus 3 is 6. 12 plus 6 is 18, so the perimeter is 18 centimeters. 3 says, estimate to draw as many rectangles as you can with an area of 20 square centimeters. Label the side lengths of each rectangle. So I know that the area is 20 square centimeters, so when I multiply the two sides, it's going to have to equal 20, which is why I wrote down area of 20, and I wrote down the different multiplication problems that could be 20. So 1 times 20, 2 times 10, and 4 times 5. Of course, you could also have 20 times 1, 10 times 2, and 5 times 4 because you're just reversing the order, but the multiplication problem stays the same. I drew my rectangles and I labeled the sides, and I found the perimeter because this will help me later on, but again, you don't have to find the perimeter, it's not asking you to. Make sure you label the sides. A is asking which rectangle above has the greatest perimeter. How do you know? By just looking at its shape. I can tell that 20 times 1 because it has the longest side length, so when they're added together, it'll be a big number. B is asking which rectangle above has the smallest perimeter. How do you know? Just by looking at its shape. By looking at it, I can tell that 4 times 5 will be the smallest perimeter because it has the smallest sides, so when they're added together, the number will be small. Go ahead and get the Lesson 18 exit ticket in front of you, ready to go, and then the timer will begin, and we can go over it after. Tessa uses square centimeter tiles to build rectangles with an area of 12 square centimeters. She draws the rectangles as shown below. Label the unknown side lengths of each rectangle, then find the perimeter of each rectangle. So, in my problem, it says that she has an area of 12 square centimeters. This is a big hint to fill in the blanks on these shapes because you know that when you multiply the two sides, it's going to have to equal 12. So looking at the first rectangle, there's a blank and then one side is 12. So I know that if one side is 12, I'm going to multiply it by 1 so that it's also equal 12. I'm not done here. I need to find the perimeter, so I'm going to add up all the side lengths. I know since it's a rectangle, opposite sides are equal. So I did 12 centimeters plus 1 centimeter plus 12 centimeter plus 1 centimeter. Even though the like numbers aren't next to each other, I still added the like numbers together to make it easier. So 12 plus 12 is 24, and 1 plus 1 is 2. 24 plus 2 is 26. So the perimeter of this rectangle is 26 centimeters. The next one, I can tell that one side is 3 centimeters. To make that 12, I multiply it by 4. So that other side length is now 4 centimeters. Again, I have to add up the side lengths to get the perimeter. So 3 centimeters plus 4 centimeters plus 3 centimeters plus 4 centimeters. Adding the like numbers together, I get 6 centimeters plus 8 centimeters, and I find that the perimeter is 14 centimeters. Moving on to the last one, if one side length is 6 centimeters and I need to make the area 12, I know that 2 times 6 is 12, so my other side length is going to be 2 centimeters. 6 centimeters plus 2 centimeters plus 6 centimeters plus 2 centimeters. 6 plus 6 is 12, 2 plus 2 is 4. 12 plus 4 is 16, so the perimeter is 16 centimeters. Now when you want to do the sprint for lesson 20, you'll find that there are two. There's A and there's B. You can do one, you can do both, it doesn't matter, but make sure you only get 2 minutes for each one and just do as much as you can. After the timer is up, I'm going to have the answers for both A and B, so make sure you're checking the correct one of what you did. Okay, make sure you're doing the correct one and checking your work for the correct worksheet. This one is for Sprint A, so make sure you're looking at Sprint A and you have the correct worksheet in front of you. This is Sprint B, so make sure you're checking the correct worksheet. Don't get A and B mixed up. This one is for B. Alright, now you should have the Lesson 20 application problem in front of you, so we can go ahead and get working on Lesson 20. The application problem says that Molly builds a rectangular playpen for her pet rabbit. The playpen has an area of 15 square yards. A. Estimate to draw and label as many possibilities as you can for the playpen. B. Find the perimeters of the rectangles in part A. C. What other information do you need in order to recreate Molly's playpen? So let's do part A first. Estimate to draw and label as many possibilities as you can for the playpen. So if I know that the area is 15 square yards, I'm going to have to think what times what can equal 15, and those will be my choices. I only found two different multiplication problems, 1 times 15 and 3 times 5. Of course, you could also do 5 times 3. I drew out those rectangles and labeled the sides. So rectangle A I labeled is 1 yard by 15 yards, and rectangle B is 3 yards by 5 yards. Now B says to find the perimeters. So since I labeled my rectangles above, I'm going to just add them up like this. Perimeter of A is 1 yard plus 1 yard plus 15 yards plus 15 yards. I put the like numbers together. 1 plus 1 is 2, 15 plus 15 is 30. So 20 plus 30 is 32 yards. The perimeter of B, 5 yards plus 5 yards plus 3 yards plus 3 yards. 5 plus 5 is 10, 3 plus 3 is 6. 10 plus 6 is 16 yards. So now I have the perimeters for both of my rectangles. C is asking what other information do you need in order to recreate Molly's playpen? I would need to know one of the side lengths to know which playpen Molly built, or I could use my answers to part B to figure out which playpen she built if she told us the playpen's perimeter. Now you should have the Lesson 20 problem set in front of you so we can start going over our new information. Number 1 says use your square unit tiles to build as many rectangles as you can with a perimeter of 12 units. So, a perimeter of 12 units means that when I add up all the sides, they're going to have to equal 12. So, what I did was for A, it says estimate to draw your rectangles below. Label the side lengths of each rectangle. So let's do part A first, and then I'll explain how we did it. Part A, we're going to draw a few different rectangles for when I add up all the side lengths to equal 12. One way I found is rectangle A, where it's 1 unit and 5 units. B, I found a rectangle where there's a it's a square, and every side is 3 units. And C, I found a rectangle where one side length is 4 units by 2 units. Part B is explaining how we got those rectangles and what the side lengths would be. I didn't just look and think, oh, these would equal 12. I thought of how I could do it. So first I divided the perimeter by 2 to get 6 because the perimeter is 12 and divided by 2 is 6. I know that when I add up the sides, there have to find pairs of the numbers that added to 6. So these pairs are possible, widths and lengths. So if you look at the rectangles and add the two sides together, they're going to equal 6. So 5 plus 1, 3 plus 3, 4 plus 2. Now it's asking, find the areas of the rectangles in part A above. So the area of rectangle A is 1 unit times 5 units. That would equal 5 square units. Of course, now we're in area, so it has to be square units. Area of rectangle B is 3 units times 3 units, which equals 9 square units. And the area of rectangle C is 2 units times 4 units, which is 8 square units. Now it says the perimeters of all the rectangles are the same. What do you notice about the areas? So all the perimeters do equal 12 units, but what I notice when I multiply them up is that all the areas are different. Number 2 says use your square unit tiles to build as many rectangles as you can with a perimeter of 14 sides. So once I add up all the sides, it needs to make 14. Using the same strategy as I did for number 1, what I'm going to do is I'm going to divide 14 by 2, which equals 7. Now I know that when I add up the length and the width, it's going to have to equal 7. So for rectangle A, I did 6 units by 1 unit, which is 6 plus 1 is 7. For rectangle B, I did 2 units by 5 units, 2 plus 5 is 7. And for rectangle C, I did 4 units by 3 units, 4 plus 3 is 7. B says find the areas of the rectangles in part A above. So the area of rectangle A is 1 unit times 6 units, which is of course 6 square units. The area of rectangle B is 2 units times 5 units, which is 10 square units. And the area of rectangle C is 3 units times 4 units, which is 12 square units. C says, given a rectangle's perimeter, what other information do you need to know about the rectangle to find its area? So given a rectangle's perimeter, you also need to know the width or the length of the rectangle to find its area. For example, in the rectangles above, the perimeters are all the same, 14 units, but the areas are all different. So you should also have this Lesson 20 data sheet. You're going to keep this with you because you need this for Lesson 21 as well. If you notice, each box is a perimeter of a different unit. For the units we go through today, you can go back and look in your problem set. We created a few different rectangles for a perimeter of 12 and a perimeter of 14. You're going to write in the width and the length and the area of those. So just like I did, go back and look at your rectangles you created, the ones you came up with for 12 and the ones you came up with 14, and then we'll use this worksheet again for Lesson 21. Alright, go ahead and grab the homework worksheets and do those on your own, and we will of course go over them in our next video. Good luck!